object-oriented programming series. Now, if you remember, when we started this object-oriented programming, I told you that one of the first things that you want to do is that before you start doing object-oriented programming, you will need to identify the actors, all right, that are in that particular project you want to write. So you probably need to do some, what do you call it now? Some kind of classification so that you can arrive at the classes, right, that you need to solve the program. So if you remember last week, we talked about the 3 different programming paradigms. We talked about procedural programming, we talked about functional programming, we talked about object-oriented programming. And then we talked about how procedural programming works, because your friend Rix, comes visiting and he's hungry and he wants to eat noodles. So what happens is that sometimes you just want to, just take the procedures, and procedures work, but only when the task is just very simple. So assuming you're just preparing food for your friend, like Aziz, you just visit and I don't want to prepare noodles. It's just to go to the nearest neighborhood shop, buy noodles, boil water, put noodles on fire, and then serve the noodles, and you're okay, everybody's fine. But if Aziz, you probably tell Anu, okay, guy, I have an event coming up. All right, maybe I'm doing a housewarming, and most of my friends they like noodles. So I think Anu, you should cook you should cook noodles for me. I'm expecting 5,000 people. Like I was explaining to us last week, it will not work for you to just say, let's do procedures. No, at this point, you're expecting 5,000 people. Procedures cannot work. Procedures are going to be a mess unless they are managed by certain people. All right. So in fact, I personally sometimes call object-oriented programming project-oriented programming, because that's what it is. You're taking something that is a task, like prepare noodles, which is the same thing we're going to do in the old, and then you're turning it into a proper project. And by turning it into a project, what you're doing is you are making this thing. What's a project? A project is something that has procedures and that has people manning those procedures. That's basically what a project is, and has a timeline, obviously. So if you say you want to make this noodles thing a project, then that means you now have to identify what the tasks are, and then identify the various people who would handle the various parts of the project. So you've identified, yes, we need noodles, all right, to be able to cook for Anu's wedding. So who are the people that will buy the noodles? Who are the people that will cut the noodles, the ingredients? Who are the people that will arrange all the things we need, the gas, the whatever, all right? Who are the people that will cook them? Then who is the person that will supervise this whole thing to make sure that everything works according to plan? So that's basically how the object-oriented programming thing works, okay? Now, the thing now is this: how do you now proceed from here? You have to identify like I told you last week, you have to identify the attributes of each of the classes, and then the job description. And we talked about all of these details. What I'm just doing is I'm just recapping. You can watch the video of last week so that if you still do not get from the recap, I just want there to be a flow into what we're going to do today. So yeah, when you look at how Rick's wedding project will look like in Python, so we'll first do the person specification. And what are we doing? We're just trying to say, hey, who are the people that are going to be in this project, and then what's their job description? So this is it. Now, the next is that these specifications that we have are called the class properties or class attributes. And then these ones, the tasks, are called the methods. They could also be called functions, all right? So these are the two things that make up an object. Every object must have properties or attributes. Every object must have methods. So attributes are things that the object has, all right? That helps make the object identifiable. methods or functions. In fact, methods actually are things that exist, are things that the function does or is acted upon on the function. So we looked at all of these in details last week. And then we began by talking about the classes. So let's move over to collab. Let me just discontinue my screen sharing and move over to collab. So, all right. So let's go to collab right now. What I'm going to do is I'm going to go through everything we did last week. So last week we began with the first step, and the first step is usually to initialize the various classes required to run your project. So we have identified that we need 3 classes of people: project manager, the procurement manager, and the kitchen manager. So the first thing we'll do is to initialize each of these classes. And to initialize means to set the boundaries, to tell the computer what you expect from each of the classes. Okay, so so that's what initialization does. Now, is it compulsory to initialize your, okay, sorry, Dolly is asking, methods are what the function are what the function that something does, while attributes are characteristics. Yeah, Dolly, that's correct. So methods are like functions, attributes are the characteristics or properties, if you like to call them that. So so for this, we have the project manager, all right? And now this is the initialization. So in this first def, you see that word def is to define. That's what the keyword means in Python. So define. We're defining this. Init means to initialize. So we are initializing this project manager class, and then we're telling Python the boundaries of the class. So we're telling Python, hey, whenever you see this project manager class, anybody that they tell you is a project manager object, these are the characteristics the person must have. So if tomorrow we say, hey, Anu is a project manager, it means that Anu must have a name, he must have a degree, he must have years of experience. All right. So to initialize a class, we start with this word self. What is this self? Self is just a word that tells that tells Python, hey, this belongs to this project manager. This self just says, okay, Python, we're talking about this project manager. So if I'm trying to describe Anu, I'm going to describe, okay, so this is Anu. That's what this is Anu itself, all right? And then Anu has a name, Anu has a degree, Anu has years of experience. So that's basically how that self thing works. It can be anything. I can change it to project manager. I can change it to anything. You see, most of these things are placeholder variables. They are not really keywords that get executed. That's why you can see us repeating it everywhere, self, 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 self. They actually throwaway variables. They don't really matter. So for a throwaway variable, you can name it anything. You can name it. I can even change this to Anu or to Aziz or to Dolly, and it's still run. All right. So that's what that self does. So we're now trying to tell Python by initializing this that for this project manager, the name must be equal to this variable called name. So we're telling Python that anytime we tell you, okay, we have a project manager named Aziz, Aziz.name should refer to that property in Aziz name. Aziz.degree should refer to the degree property. Aziz.years of experience should also refer to the years of experience property. All right, so that's basically what this first part is doing. And again, like I told you, it's not compulsory to initialize a function. All right, you can just start talking about the functions method at the time and it will still run. Okay, but standard practice, just initialize your function and we'll all be fine. So if you notice the next place, we have another def. Sorry, I mean initialize your class. We have another def here. Now, you will notice that we have def here and another def here. But this one here, Python knows that this is the properties. Python knows that this is the method. How does Python know? By default, the def character is used to start up either a function or an attribute. But because of that init that is in this one, Python now knows, okay, so this is the attribute. Why? Because we're initializing it. You don't initialize functions, you only initialize attributes, right? So the moment Python just sees this init beside a def, Python knows, okay, this is the class properties of the attributes. Then for this other one, Python says, okay, since there's no init there, that means these are the methods, all right? So that's how we, and a method is a function. In fact, a method is a function, but why we call it method is that it belongs to a class. So any function that belongs to a class is called a method. Any function that does not belong to a class is called a function, just ordinary function, all right? So we have done for the project manager, we have done for the procurement manager, and then we have done for the kitchen manager. So after initializing a class, by when I say initializing, means set the boundaries. You're setting the whole look and feel of the class. So you're telling Python, hey, these are the methods, these are the attributes. The next thing that will now happen is that we're now going to instantiate the class. So to instantiate a class, we technically, like, we're creating human employees to occupy these roles. So we create a new instance of that class. And sometimes you would have seen, especially for those of you who do machine learning, you would have seen something like this. Maybe when we say model equal to sequential. All right, that's for if you're doing convolutional neural networks or even scikit-learn. Yeah. So what we are doing is this. We are trying to instantiate a class. So this sequential is the class. This model is an instance of the class. All right. So that's what we did here. So we're telling Python that we are creating a new PM, and this PM is a project manager. But because we have told Python that anytime we're initializing, anytime we're defining a new object, we have to supply all of this. The moment we type, let me just bring that code out again. The moment we type PM equals to project manager, so Python expects us to, okay, sorry, I need to run all of this so that Python will know what I'm referring to. That's why it's not giving me the autocomplete. Okay, so when I say PM equals to project manager, you can notice that the moment I want to instantiate it, the IDE that I'm using, either Collab or Spider or whatever, is going to ask me for three things: name, degree, and years of experience. Exactly because that's what I told Python that every project manager will have. Now, if I stubbornly decide to go ahead and continue, and I say pm.name, and I try to output it, Python is going to give me an error and say, hey, the init method for this project manager is missing 3 arguments, and none of it was supplied. So let's supply the name. Sorry. Let's supply the name here. Let's say Aziz, since Aziz is the project manager. And then the degree, PhD, and the years of experience. Let's supply that as, sorry, it has to be in numbers. So let's supply that as 30 years of experience. So now, when we now call this PM, dot name. So you can see that Python now says, okay, I recognize that this is as is. So this is the object and this is the instance of that object. So Aziz is the project manager. All right, so that's basically what we do when we instantiate an object. We are trying to now create people to fill those roles. Okay, so please, if you have any questions, just put it in the chat, or if it's a verbal question you want to ask, please, you can raise your hand, and at any point in time, I'll stop and then we'll talk about it. Okay, so that's what I've done here. I have initialized the project manager, I've initialized the procurement manager, and I have initialized the kitchen manager. Remember, we had two kinds of kitchen manager. We have kitchen manager 1 and kitchen manager 2, and both of them are kitchen managers. So the kitchen manager 1 is a woman called Sue. The second one is a man called Robert. 7 years of experience, 6 years of experience. All right. So like I told you, when we have finished identifying all the objects and instantiating it, then the real beauty of the task now begins. So we now start to talk about things like to start the cooking, because the wedding has to hold. So we're not here to really talk. We're here to cook noodles. So the first thing is that before the project begins, the project manager has to create a plan. So that plan creation is one of the functions of the project manager. You can see it here, that one of his tasks, or one of his functions, or one of his methods, if you like, is to create a project plan. And we'll just put, this is my project plan here because it's just a placeholder, but it can be a lot of things. It can be, you know, drop map, draw work breakdown structure, assign task, etc., whatever it is. So for this project to begin, the project manager has to give us the project plan. And to do that, we have to call that method. We have to ask him, give us project plan. So when we do that, he brings out the project plan. So now project plan is ready, and we have seen the work breakdown structure. We've seen the Gantt chart that says, okay, so it begins with how we're going to go and buy. And the person responsible, and that's another thing about project plans. You have to have a task and a person responsible. Like I told you, I like to call object-oriented programming project-oriented programming, because that's basically what we are doing. We are just identifying tasks and actors that are responsible for those tasks, so that when we create those actors, we can call their functions or call their methods or call any attributes that belongs to them in the course of running our program. So in this case now, project manager has given us his plan. The next thing we now have to do is to go and buy ingredients. So that task is a task that should be carried out by the procurement manager. All right. So when we run that, and we just tell procurement manager buy ingredients, okay, because I've not initialized the procurement manager, it's giving that error. So let me just initialize the procurement manager. So when I run this again, it's going to tell, okay, so I'm going to the farmer's market. Now, after the procurement manager buys what he wants to buy, the next thing that happens again is that he has to receive those items into the store. All right. So when you run this again, it says, okay, I'm receiving the items into the store. And then that's for procurement manager number 1. Then there are 2 kitchen managers. One of them has the task of preparing the ingredients, while the other one has the task of monitoring the cooking, so that there'll be division of labor, you know, stuff like that. So you call the one that has to prepare the ingredients, let that one start preparing the ingredients. And as it's doing that one, you call the other one that is doing the cooking. So you will just be putting the ingredients and monitor the cooking. So that's how you keep building on tasks until you get to the end of the project where the noodles are served. So that's how apps are developed. That's how apps work. But like I told you, this is a very simplistic, it's very, very simplistic in the sense that we have not taken things like loops and all of those into consideration. But now let's take things a notch higher, because what you see now is just simplistic. But object-oriented programming has 4 dimensions or 4 cardinal principles. And the principles are number one, inheritance, encapsulation, abstraction, and polymorphism. So we're going to look at this four, and then we're going to touch one or two things that will help build the foundation for the advanced class Tom is going to have next Saturday. And also the final class we'll have upper Saturday, and we'll start our project. All right. So the first thing in object-oriented programming is inheritance. So inheritance refers to the process by which a child class inherits the properties and methods of a parent class. So let's look at our modules project again. Remember, when we were talking about this project, we had just three people in the task. We had the project manager, who was the overseer. We had the procurement manager, who was to buy things, and then we had the kitchen managers. All right. But now, remember, we're in the period of COVID, okay? And anything can happen. So what if the project manager gets COVID and he is ill? That's a very bad place to be, because it means the remaining two people will not have a guide, and they will not have a person overseeing the linkages in all the projects. So it means that we might need to get an assistant project manager whose role is like that of a project manager, all right? So, but then remember that two captains cannot be in a boat, because if the project manager is around, it means that assistant project manager is not working, it's not performing in that capacity. So for the time being, what should the assistant project manager be doing? He can't just be sitting down and idling away. It will be wasting our system resources. And that's one of the things that you want to avoid. You want to avoid system resources being wasted. So if you just create an assistant project manager object that will just sit there and just not doing nothing, waiting until the project manager catches COVID before he can start work, that's just a waste of resources. So what do we do, to ensure that, okay, this COVID issue does not hamper continuity? So we'll have to now create an assistant project manager who is like a project manager. So assistant project manager is obviously a project manager. He can perform everything the project manager can do. He has all the features the project manager has, all right? Just that because he's not active, we're going to just give him the task of be snapping selfies or just be snapping pictures of the process by which we are building and cooking these noodles. So that's what we're going to do for this assistant manager class. And to do that, the first thing we do is to make the assistant manager inherit the characteristics and the methods of the parent class. So how do we do that? We start by defining the class assistant project manager as a child of project manager. You do that by putting the project manager in this parenthesis. Okay. Then when you have done that, the next thing you'll now want to do is to initialize this project manager. Remember, we told you that this project manager has the same characteristics that this other project manager has. So to initialize it, we have to again go the self, name, and all of that. But then if we want to tell Python that we want the assistant project manager to inherit everything, that every trait that the main project manager has, we use this method called super. Super means to get the parent class to transfer all its attributes to this person. So you will notice that by writing this super.init here, name, degree, years of experience, we are not doing this again. Self.name equals to name, then self.degree equals degree. We're not doing that again. Why? Because we are telling Python now, hey, just go back to the first time we declared it. Everything is the same, just the way we declared it with the parent. So that's why we're using this super here. All right. Another way you can do it if you don't want to use this super is to say project manager dot init. So you're telling Python, hey, go to the project manager class and initialize. But most times why I prefer using the super is that number one, it's compact in the sense that it's short. You don't need to write the whole name of the class. And number two, by just saying super in any place, I already know that, okay, we're dealing with an inheritance situation. But if I just type project manager dot init here, and sometimes you might just be confused and might just, oh, okay, he's trying to inherit this. But by just saying super here, I already know that we're inheriting everything from this project manager class. So it just makes the code a bit more readable. Okay. So the next thing we're going to now do is to do this create project plan. Again, we're going to make this guy inherit everything from the project manager, because I told you an assistant project manager is just like a project manager. He can do everything that the project manager does. So he too can initiate project plan, and it has to be like the same way the original project manager, that's the parent class, does. And then he too can coordinate a project. Again, we're using super to show that, yes, you can do it the same way this guy does. But then, because like I told you, we don't want redundancy, we have to assign him the task of taking pictures. So we'll now create that. Whenever I say assign a task, we're talking about creating a method. So we create that method, all right, called take pictures. So you will notice that the parent class, which is the project manager, does not have this, but the child class has it, all right? So you can notice that the inheritance is not complete, it's not total. In this case now, the child, is having a behavior that is different, a bit different from the parent's behavior. But there's some children that, you know how these children work. They resemble their father, they do the same thing that their father does, they work in the same place, everything is just like the father, so that's how that one is. But this one is not a total inheritance. There's just a small difference. And again, you need to define all of this at the beginning of your program. Now, you don't need to have all the answers. You see, that's why programming is an iterative venture, it's an iterative project. In programming, we use something called Agile, all right? And what is Agile? You run till you get to a brick wall and you review. You change plan, So you don't use a waterfall method of project management to run a software project, because sometimes, like now, we did not know that we needed an assistant project manager from the beginning. So maybe the owner of the app just told us, what happens if something makes the project manager class not available? Oh, okay. I think we need an assistant project manager. So we are building that now. So once we do that, we will now initialize the assistant project manager class. And then, yeah, we have an assistant project manager called Kehinde. He has a bachelor's degree and he has 10 years of experience. And then when we run this, so you'll see that Kehinde, yeah, has done his project plan, and then to get him to take pictures, he has to tell everybody to say cheese. So Anu, go ahead with your question.
Okay, so I just wanted to ask as regards the assistant project manager.
Right.
What if they don't need the same things? What if the assistant, we just need the person to have a name and a degree? We don't need him to have years of experience.
Fine. We'll just delete this here. And then delete this in the inheritance. That's all. Finish.
Okay.
Yeah. So, in fact, if we don't even want it to inherit the stuff, we can even just delete this whole thing so that the system will just know that, okay, you don't want to inherit the parent's objects, as in, you don't want to inherit the parent's attributes. You only want to inherit his method. Do you understand? So, for example, you don't want to inherit your father's surname. That's one of the things. So you can see a child might say, you know what, I want my name to be Anolua Anolua. I don't want to have my father's surname, It's totally allowed in Python, but some languages might have a way of enforcing all of those, but Python, and that's one of the things that makes other programmers hate Python, because they think Python is too lax with rules. And that was actually why Guaido created Python, because the rules at the time were hindering programming. When I started learning programming in Java, for the first like 3 months, you would just be hitting error upon error upon error. After the first 3 months, I actually packed up my everything. I just packed, I'm not doing it again. Then I saw some other guy that encouraged me, okay, we'll be doing together, I'll be training you up. Then I started again. Any small thing you do error, any small thing you do error. So in order to prevent that frustration, because programming is an intense endeavor, you don't really want to, be doing that error. You just get frustrated. You probably use the 1/3 of your day debugging errors, So that's why Python relaxed most of these rules. That's what Python did. Okay, so now that we have done that and we have, initialized and we print this, you can see that this output is my project plan, and everybody say cheese. One will call this take pictures method. So that's what you call inheritance. Inheritance is the process of getting to, take a parent class's method. Now let's talk about encapsulation. Encapsulation is the process of hiding a class details when I talk about details, either a method or an attribute inside a black box to prevent unauthorized access. So this is how it works. Now, we're looking at this our Noodle project. So assume that we do not want any random person to just be able to ask the assistant project manager to just take pictures unless they have gotten permission from the PM. You understand? There's some people like that in your office who you probably know that you can't just send them on an errand unless you have gotten maybe an office assistant or something, unless you have gotten clearance from the boss. Sorry, Malga, let me just send this office assistant to get me buy me something. So if we want to do that, one of the things we can do is to encapsulate that attribute or that method. All right. And then ensure that when we do the encapsulation, nobody can just call that method, all right, from anywhere. How do you do encapsulation in Python? Now, there are 2 levels of encapsulation. The first level is to make an object protected. The second level, which is the highest level of encapsulation, is to make an object private. All right. So for protected variables, you use a single underscore. For private variables, you use a double underscore, also known as dunder. So you probably might have heard somebody say dunder method or something. Dunder actually means double underscore. All right. So let's now say that we want to encapsulate this assistant project manager's ability to take selfies so that nobody can just call it without getting permission from the project manager. So we have to create 2 extra methods here. Remember, everything remains the same. Every of his earlier methods remain the same. But here now, we now have to create 2 extra methods. So what we now have to do is to create the first method called obtain permission, all right? And this one is the process of getting permission from the project manager. And then this one is now to take pictures. So by putting this take pictures with 2 underscores in front, nobody can call this function, this method here. Nobody can call it unless they go through the obtain permission method. So they must obtain permission before they do this take pictures. So let me just show you an example. Now, let me comment this out. Sorry. Let me just comment this out. No, not that. This one. Okay. And that's another, come on now, what's happening? I'm trying to, I just keep pressing Control hash, and then when you press Control hash, it just minimizes. Sorry, it's actually Control and the forward slash. So in Collab, if you want to, what do you call it now? If you want to comment something out or uncomment something out, is Control /. So now, let's say I try to force this assistant project manager to take a picture without obtaining permission. This is what will happen. So I'm just going to call this APM and initialize the Jumoke and everything, and then say, oh yeah, take picture. This is what is going to happen. Python is going to tell me no, it has no attribute take picture. But you can see the attributes there. The take pictures is showing there. So why can't I access it? The reason is simple. By using this double underscore, it has now become a private method, all right? You can only access it from inside the class or by using something called name mangling. And name mangling, I don't want to disturb you with it, but I can show you an example of it later. So, right now, to enable us do this, we will have to get permission, all right? So let me uncomment this so that this obtain permission can work. And then we can obtain the permission, all right? And when we obtain permission and run it, Jumoke can now tell us everybody say cheese. So you will notice that this method called obtain permission actually returns self.takePicture. So it's what actually, the moment you obtain permission, it's like automatic that just says, you know what, okay, yeah, this is my permission, now take pictures. You understand? So that's how it works. That's why when we call that obtain permission, it just returns self.takePictures for us, which is everybody say cheese. So that's what encapsulation is. Encapsulation is the process of making an attribute or a method private to a class so that nobody, either by mistake or unintended thinking, can just hit that attribute. And it's the same thing like in football. For example, in football, a goal is only counted when it's a player that kicks it in, correct? So we have to encapsulate, if we're creating a football game, we have to encapsulate that score goal method, right? So that it's only when a player kicks the ball or something that a goal is counted. What if the ball boy, the ball boy, those boys that are on the sidelines that throw the ball, what if they throw the ball into the net of the opponent? Are we going to call it a goal? No, we're not going to call it a goal. It doesn't count. In fact, it can happen, So that's what encapsulation does. Encapsulation restricts some other parts of the app from being able to perform some certain actions on a particular object. Okay, so that's how encapsulation works. The third is abstraction. And what is abstraction? Abstraction is the process of trying to. Okay, now let me ask the question. Aziz, are you there?
Yeah.
Okay, lovely. Yeah. Now, if I tell you right now, a plane just passed my house, what comes to your mind?
Maybe I will think a plane passed by your house. Maybe.
Yes, a plane just passed over my house right now. So if I just tell you a plane just passed over my house, when I mention plane, what comes to your mind?
Maybe I will think of where is that place, or I don't really know what I would think.
Okay, I know. Okay, let me ask Anu. Anu, if I tell you that an aeroplane just passed my house right now, when I say aeroplane, what picture comes to your mind?
Something flying over your house.
That's number one, something that flies. So it probably has two wings, So something abstract just appears in your head to say, okay, when he said plane, It probably just has 2 wings, 2 engines, but that might not necessarily be correct. It might actually be a Boeing that has 4 engines or something. But you just know that when I said plane, I know what you're talking about. You understand? Without the details of how many engines he has, how many, that's what abstraction is. And we practice it a lot every time. If I tell you a girl just left here, you'll know what I'm talking about. You don't know whether the girl was wearing a trouser or whether it was wearing, all those details are not necessary. That's how abstraction works. Abstraction is just like that process by which you create a mental picture of what an object should have. So when we have, for example, now, remember we have 2 kitchen managers. We have kitchen manager 1 and kitchen manager 2. One prepares the ingredients, all right? And then the other one, the other kitchen manager does the cooking, So each of these 2 kitchen managers require a table. Now, when I say table, what comes to your mind? Something that has 4 legs, right?
Yeah.
But not all tables have 4 legs, right? Some have 3. Some are just a wedge, So abstraction demands that when we are telling Python that, hey, we want all kitchen managers to have tables, we need to allow each kitchen manager object decide what kind of table suits them best. So let's see how we implement it in code. So this is the kitchen manager class, as usual, like the first one. But then you would notice that what we have done is that we have left this thing here. We had self, name, years of experience, and then we have said self.name, self.years of experience. There is one more attribute that every kitchen manager should have, and that is table. Each kitchen manager should have tables. But you will notice that we did not initialize it here in the list, because normally we're supposed to have either added table type or something here, but we did not add that. And the reason is simple, because we are trying to tell Python, hey, allow everybody determine the kind of table that they need. So that's why we have this self.table type here equals to none and not one of the requirements. So as usual, they are going to prepare their ingredients. As usual, they are going to monitor their cooking and all that. But then we're now going to have a method here that sets the table type that each of them requires, because each of them need to have their own table. So it means that this class must have that ability to decide what kind of table type that we want. So this first one here is kitchen manager 1, and this kitchen manager 1 is Janet, all right? And Janet is the kitchen manager that does all the gathering of ingredients and preparing of that. Now, there is a special kind of table made by IKEA that can help you do all of that. IKEA is a furniture company, okay? So for this one, we will have to set this table type and tell Python that, hey, for kitchen manager 1 objects, it's only IKEA table we want them to use. So when we print that, you see IKEA is printed. Now, for kitchen manager 2, remember, kitchen manager 2 does a lot of all the mixing and all the cooking and all of that. So there's another kind of table that suits that task. It's called La Vida, all right? So for kitchen manager 2, we'll allow him set his own table type, the type of table that requires to La Vida, all right? Again, this is just simplistic. So what we have done right now is to abstract that table concept, it's just like saying, okay, Aziz, one of the features that we need every project manager to have is a private jet. So, but then we cannot force Aziz to use a Boeing or to use a Cessna or use an Embraer. We'll just allow the person decide what kind of private jet they want to use. So the set private jet up method, they will allow them decide the brand, the kind, the size, and all of that. So that's one kind of abstraction. And you notice that this kind of abstraction is such that it's just the one attribute that we are abstracting. Every other one is required, is okay. But in some cases, we want the whole class to just be abstract, all right? So what do we do in that case? We have to import something called ABC, Abstract Base Class, is a Python module. Like I told you, Python was not really designed with all of these things in mind, because Python just wanted to make programming easy. But people that were coming from other languages, Java and Co., they needed that same rigidity that, you know, Python that was not known for, or Java was known for. And so they started, you know, trying to create things that would give them the same look and feel that Python was known for. And one of the things you would know about Guido Van Rossum, that's they call him BDFL. Whenever a person creates a project like Python or a language like that, they call the person the BDFL, that's Benevolent Dictator for Life. So he's the person that determines what happens to the language or the model, okay? So being the BDFL, Guido did not want that same imposition of all the things that Java and Co were known for, because that was what was frustrating people from learning programming. So he wanted the language to be as entry level as possible, all right? So what he did was to say, okay, you know what, we're not going to change the Python's ease of syntax and all of that. We can just create a module that can allow you to do what you want to do. So that was why they created this abstract base class module and abstract method, all right? So we have to import this ABC from ABC, also import this abstract method from ABC. Now, when we're doing that now, in this case, what we are doing is, you can see that we want the class to be abstract. So this procurement manager class is abstract, all right? And we are not passing no self dot anything, because it's an abstract class. We're not implementing anything. We want the procurement managers to be able to implement everything by themselves on their own, okay? And then the methods too. You can see, yes, we want them to be able to buy ingredients. We want them to be able to receive items, but we don't want to determine all of that. We don't want to determine everything for them. We want them to decide how they want to buy ingredients. We want them to decide how they receive items. Why? Because in some organizations, they have large and small inventory. So the person that receives the large inventory is different from the person that receives the small inventory. The person that also just, you know, or makes those orders to be different. So in order to ensure that level of abstraction is maintained, that's when we create something like this, all right? So now that we have created the abstract class and we have done this procurement manager to be abstract, that's why I put this ABC here. We'll now start defining the project manager. So we'll first create an instance, a subclass actually, of a project manager. And this one we'll call the procurement manager small, because this procurement manager handles only small procurement. So he only does the small procurement. And he's a child of the procurement manager class, all right? And now we will now define the inits. So we'll say, yes, the procurement manager, as usual, he needs to have a name and years of experience. And then we'll define the name and the years of experience. If you look at this, you'll notice that we don't have any super, because there's nothing to inherit. The parent class is abstract. It doesn't have anything for us to inherit from there. Now, for this procurement manager small, he too will have buying ingredients. But again, abstraction demands that we tell the Python to say, okay, you know what? Let this guy decide what kind of things he wants to buy based on his job description. So this guy will now return, I only buy small things. And then to receive to means that he only receives small things. So that's what we do for this. So same thing when we call, okay, let me just run this so that we can run this one. Now let's initialize the first small procurement manager called Kemi, and is 25 years of age. So 25 has 25 years of work experience. When we run it and we say print there's this procurement manager small name. It gives us Kemi, 20 years of experience, gives us 25. Then we want you to buy ingredients for us. Kemi will tell us, hey, I only buy small things. So that's how this one works. Now, for this one too, we now create a procurement manager large class, all right, which is a sub of the procurement manager class. And then we also define the attributes or the properties, and then define the methods. Again, we have to, use this, and then when we run it, this guy will tell us that I only buy large things, all right? So that's how it works. And that's what abstraction does. And you'll notice that we put something here, this abstract method. This thing is actually called a decorator. And we're going to talk about decorators in the last day of this of class. We'll talk about decorators, constructors, generators, a lot of all of these special functions that have to do with object-oriented program. Because by the time you see a full Python script, you're going to see all of these things inside. And you're not going to be wondering, what's this? What's this at? What's this one that starts with 3 question marks, 3 columns? What's this one that starts with hash? What's this one? So in order to prevent us from seeing all of those and getting worried, we're going to have a class that deals with all of this. Things like these decorators, generators, doc strings, and all of that relates to a function. So those are the 3 things in object-oriented programming. Then the last one is called polymorphism. What is polymorphism? Polymorphism refers to the ability of a child, class, variable, or method to have the same name with the parent, but actually behave differently. So based on the example we just showed, you can see that PM large and PM small, they have the same buy ingredients method, but they do different things. They return different results. So while one buys large things, the other one buys small things. So that's polymorphism. It's just something that you can do to enhance the quality of objects that you're creating. So these are the 4 cardinal principles of object-oriented programming. Yes, it's a very bad child, very, very bad child. Okay, so that said, I can either stop the class here and take questions, or I can just talk a bit about functions, because when you now start doing object-oriented programming, you would notice that one of the things you do are create methods, which are functions. So sometimes you might need to create a function that is more complex than just def this print name. So that's the essence of this session on functions. So what will happen is this. I probably will stop here, and then after the next class that Tom is going to do, we're going to touch this. Or should I just touch it? Which one do you prefer? Which do you prefer? You can type in the chat, or you can unmute yourself and say. Okay, so we can keep going. Okay, great. Let's touch. Okay, great. Okay, so let's just touch it. Now, let's touch it. Let's touch it. All right. So what are functions? Very simple. A function is any group of code that you use to perform a task on another variable. That's what a function is. So there are like 6 different classes of functions, but I'm going to talk about 5 of them today. And then subsequently, in that last class that we're going to do, we're going to talk maybe like 1 or 2 more, and then it will become very clear. So let's talk about the first type of functions. The first type of functions are functions that accept a definite number of parameters. So what do we mean? In this kind of functions, we know the number of parameters that we want to have. So for example, let me just insert a code here. In this one, I just use this example here of subtract. So we want to create a function that subtracts, and we know that we want to subtract x from y. So to do this, we just create this function and ask Python to return x minus y for us. So what you have done by this xy here is to create the boundaries, the parameters. That's what they are. They're either called parameters or arguments. Anyone you call them is okay, it's correct. So, but I really like to call them parameters. So when you come here and type subtract, automatically Python is expecting you to put the two things. So let me come here and call that function. So I'm going to do that function called subtract. You can see that when I put this, Python tells me I'm expecting two things from you, your x and your y. So let me put 5 and then let me put 1. So when I run that, Python knows that I need it to return 5 minus 1, which is 4. So this is when I know how many parameters that are in a function. So if I know that what I want to do needs maybe three variables, so I will just do it like this: x minus y minus z, sorry, z, and then I can add one more here to make it maybe 2. So when I run this, Python knows that I'm asking for 5 minus 1 minus 2. So it will give me this. This is what you do when you're creating a function, when you know the number of parameters that you want. But sometimes you don't even know the number of parameters that you want. So in this case now, we want to create a function that accepts an unknown number of parameters. Now, let me give you a secret. Whenever you are dealing with an unknown number of anything, whether it's unknown number of parameters, unknown number of items, unknown number of objects or whatever, you must use a for loop. A for loop is like your only ticket away from the unknown. So in this case now, we want to create a function that multiplies, but we don't know how many things, or we don't want to restrict the number of things that we want to multiply inside of here. So if we don't want to do that, we will have to use the what do you call it now, asterisk, and put args here. This asterisk args here is a throwaway variable. It's nonsense. It's a nonsense variable. It doesn't go into production. It doesn't go into runtime. All right. It doesn't have any value. It's just a placeholder so that Python will know that, okay, I'm expecting a list of arguments that we don't know what it is yet. Now, for you to have a for loop, most times, or not most times, sometimes you need a counter. So a counter is something that keeps scores when you want to start your for loop. In Java and in C++, I think, C# or C++, I can't remember now, you would see most of these counter things more pronounced. But in Python, it's a bit lax. So this is just like a C++ implementation or a C# implementation of how functions work. So I need a counter to keep my scores. And then all I will now do is, since I don't know the number of arguments inside, the loop will run once, pick what is there, add it to my counter will increment, the loop will go again, pick another one, add it to what my counter has, it will increment like that. So that's what this result variable is doing. It's keeping scores. So I start the score from 1. Why did I start the score from 1? The reason is here. I just told you that when I'm doing an addition or subtraction, the results of the counter has to start from 0. But while I'm doing division or multiplication, the results have to start from 1. Why? Because anything times 1 gives you that figure. So 1 is like the base. So this how it is. And I'm going to run the for loop now. I'm going to tell Python that for I in args, I want to believe that we're all gurus, so we know how the for loop works. This I here, all right, is any item inside these arguments. That's why we have the for I in args. Anytime you're using, it can be anything. We can even call it for X in args, or for J in args, or for arg in args. It will still work. Okay. So what we are doing now is we're telling Python, hey, for every item inside these args, we want you to go and increment the results by multiplying it by I. So if we put 1, if you put 2 inside here, already the scores begin counting at 1. So we want to multiply what is here. It will just be 2 times 1, 2. If we add 3 inside here, making it 2 and 3 inside this args, all right, one will now want to call the function. What Python will do is Python will say, okay, scores start at 1. So the first thing there is 2. 2 times 1, 2, all right, times, the next thing there is 3. 2 times 3, 6, times, the next thing there is, so it keeps incrementing like that while using that variable called results as a counter to hold scores, all right, like a short-term memory thing. So that's how this function runs. If I say multiply 2 and 3 and I run it, it will output 6. What if I say multiply 2, 3 and another 3? It will output 18. What if I add another 2 and another 5 and I run it? So it just keeps accepting an unlimited number of arguments. Why? Because that was what I specified. I told Python, hey, I don't know how many parameters, but just allow any number of parameters they add, let it just flow, all right? So that's what happens here in a function that accepts an unknown number of parameters. Remember, if this function was addition, so let me just call this function addition, all right, instead of multiply. Let me just call this addition and add. Instead of having 1, I will use 0 because 0 plus anything is 0. Okay, so that's why I use 0 as the initiator, as the initiation value of the counter. So I'll now say for I in args, result equals to results plus I instead of multiplying, and then return the result. So now I will now call the addition function. So if I have only 1 here and I run it, Python will give me 1 because 1 plus 0 is equals to 1. If I have another variable here, I will run it. Python will give me 3 because this 1 plus the initial 0, which result is, it will give me 1. Then add 2 to that 1, it will give me 3. All right. So that's why you see us doing this. Result equals to result plus 1. It's just to tell me that the moment you get what the new result is, increment it and make it the new results variable. Increment it again, make it the new result variable. So this result variable will keep changing and changing and changing and changing until we run out of arguments or parameters here. So that's how we have this one here. Now, sometimes we want to put keywords, all right, instead of variables. So in this case now, we want to get the perimeter of a rectangle, length and breadth. So perimeter of the rectangle equals to length times breadth. That's what we want Python to return. When we are, oh, sorry, I spelled this wrong. When we are creating this function, we will just put in the keywords that we want. All right, so these are the keywords, length and breadth. All right, so we will now tell Python that the length is 3, breadth is 4. Then we'll run it. So it's just going to give us 12. So it will return length times breadth. Okay. You can, let me see. Okay. So let me just look at the fourth one, which is, again, an undefined number of keywords. You don't know the number of keywords that you have here. You might try to have length, breadth, width, depth, whatever. We don't know at the time of writing this function. So we want to create that. To create that, you have to use this ** quarks. Remember, the first one is args, that's for arguments. This second one, quarks, is actually keyword arguments. That's what this quarks means. I'm sure you must have seen it in functions, and you'll be wondering what's a quarks or all that. Anytime you see quarks as the parameter of the argument and with 2 asterisk, it means they're telling you you can enter any number of keyword arguments. But if you see just quarks without the 2 asterisks, it means that you only need to enter the keywords and the way the function defines it. So as usual, we want the perimeter of a triangle. Now, actually, a triangle has just 3 sides. So it should be opposite and opposite, adjacent, and the hypotenuse, all right? So because this thing is a keyword argument, that's this quarks here, every keyword should have a value that it's pointing to. For example, if we want to use this keyword here, name, first name, it has to point to somebody's name like Aziz, Anu, Dolly, or someone. All right. We can do something like this, names equals to an empty list, but you can see that it's pointing to something. We can't just initialize a keyword and just leave it hanging there. All right. So it must be pointing to something. So in this case, we will have a for loop. Remember, I told you that whenever you are creating something for unknown, it means that you have to run it a continuous number of times for you to be able to determine what the results are. So you have to use a for loop. And like I told you again, I like to use this result equals to 1 as my initiator when it's a multiplication challenge. If it's an addition challenge, I like to use result equals to 0, all right, as my initiator for my counter variable result. So the for loop I'm going to use is this: for key value, all right, in quarks items. What is this quarks? Remember, I told you this quarks is just a nonsense variable. Is a nonsense variable, is a keyword variable that we really do not, Python does not consider as a variable when it's running things. So what we are going to do is we're going to say for key stroke value in quarks items, print out result equals to result times just the value, leave the key alone. Remember, the key is the keyword. The value is what it carries, the value it carries. So you can see here we have the perimeter of a shape, and sorry, let me call this perimeter of triangle. I'm sorry. So perimeter of triangle. All right. Now, so this perimeter of a triangle has 3 parts: the hypotenuse, the opposite, and the adjacent. Now, you'll notice that I also added the value of each of these items. So the hypotenuse is 2 cm, the opposite is 3 cm, the adjacent is 5 cm. Now, this is just for example. I know the hypotenuse is really the longest side of the triangle. So by doing this, when I run this function, Python gives me 30 because I've told Python that return result times value. So multiply this times 1. That's the first keyword. Remember, this is the keyword, sorry. This is the keyword hypotenuse. This is the value 2. So I've told Python for everything in this, for the keyword and the value in this quarks items, this whole thing here is the quarks items. So I've told Python just to return only result times value, leave the keyword out, just pick the value. So for this first one, it will pick the 2, multiply it by this one, which is the result. 2 times 1, 2, it will hold it. It will loop again. For this second one, it will pick the value, it will leave the keyword, which is opposite. You just pick the value 3, multiply it by that 2 that it has before, making 6. It will loop again. For this one, this is the adjacent. It will multiply it by 5, which is just the value because we don't need the keyword. So that's 30. Remember, we have these 2 stars here, which is, we don't know the number. It's an unlimited number of arguments. So we can actually decide, okay, there's another part of the triangle, but it shouldn't be. Let's just say a triangle. A triangle has 3 parts, but let's say this our triangle has 10 parts or 500 parts or whatever. So let's add another part. Let's call it, so have hypotenuse, opposite, adjacent. Let's call this one vertically aligned. All right. And then let's call this equal to 5. If we run this now, we'll have 150 here. Let's say we now decide our triangle should have another part. Let's call it something else. So as we keep adding those parameters, Python just keeps looping, picking, looping, picking, multiplying, looping, picking, multiplying. So that's how this function works. Now, the last function we're going to look at for today are functions that receive functions as input. There are some languages that do not allow this. But like I said, Python decided to break all the rules. And that was why Guaido is still, well, some people still hate him today because, you know, some people like things that are very difficult. But many people, and that's all of the hatred Java programmers and C programmers have towards Python programmers because they believe we're not programmers. So you have everything. You have not done encapsulation. By the time you do encapsulation, right? So if we do encapsulation the way Python and we achieve the same results as it, then we're happy. You know, it means that see, there's no prestige in suffering, and that's what I try to tell many programmers who think that one language is more prestigious than the other. I'm a Java programmer. No, there's no prestige in suffering. You're just suffering, all right? If the two can give me the same thing, why am I suffering? For example, like now, everything I do in Excel, I can do it in Python. But I will do it using pandas. I will do it with like 20 times more suffering than I would do it with Excel. Why do I want to suffer myself? I'm a pandas programmer. No, I would rather use Excel, save time, save my convenience and everything, and do what I have to do. There's no benefit in the suffering at all. All right. It's only when maybe an interview demands that, okay, now you must do this in pandas. Yeah, it's okay. Let me now do it in pandas, but I'll just grudgingly do it. But not like I will now sit down and say, yeah, I only program in pandas. I cannot do spreadsheets and any other thing. No, that's not. In fact, that's one of my first rules of programming. You must not be romantically attached to any tool at all. So whatever works for you is fine. All right. And that's one of the things that happens in Python. Python is lax about a lot of things, a lot. In fact, one of the things about Python is that in Python, you don't declare variable types. For example, if you want to declare a variable in C, let me say you want to declare, maybe you want to declare Aziz as a variable, or let me just say, I want to declare Aziz name. All right, so let me just say name variable. As you're declaring this, you must declare the type in C# or in Java or whatever. All right, and then you will now declare the variable and all this stuff. And sometimes you would use like 3 lines or 4 lines just declaring variable. You have not even started the code. But Python will just tell you, hey, let's do this. For Java, just to print out hello world, you have to type 27 things just to print out hello world. You have to type about 27 things. Public, private, args, strings, this, that, this. You now open another one. System.line.out.print. At the end, you now put hello world in brackets. But in Python, all you just need to do is just to say print hello world. And when you do that, the Java programmer is angry. You're not a programmer. How can you just be able to print hello world just by writing? Okay. So, like I said, these things, some of them are not transferable to some other languages. Some other languages, you can't receive a function as another function. You can't receive a function as input into another function. So let's use this. This first function here is a function that adds ages. This function is a function that multiplies ages. So this one just returns x plus y. This one returns x times y. Now we have a third function, which we just want to call anything. So this one, let's just call it anonymous, all right? And if you want a function to receive a function as an input, you have to use this keyword func. So Python knows that, okay, I'm expecting a function inside here as part of the arguments in this. And then what I want to return is the function that we are calling an x and y. So in this case now, the anonymous function, if we call it and we'll pass this function called multiply ages into it and 3, 4, when we run it, it will give us 12. If the func we are passing into it is the add ages func, all right, when we run it, it will give us 7. So this just gives us the leeway to have a list, and of course we can use a for loop to populate this. So it just gives you an ease of automation, and that's why I told you that Python is like, see, if machine learning were being done in Java, there will not be more than 200 machine learning engineers in the world because it will be crazily expensive, crazily hard to do, you know. But because Python has all of this ease of doing all of this, that's why it's like the language of choice for machine learning and all of that, so that we can concentrate on the maths and all of those plenty things that we have to do instead of now adding program syntax to all of that. So that's where we're going to stop for today. All right. And if you have any questions, let's just take it now. But if not, we would just head straight for tech chats.